Certainly. Command Query Responsibility Segregation, CQRS, and the mediator pattern are architectural patterns that can be effectively utilized in ASP NET Core to manage complexity and improve scalability in applications. Command Query Responsibility Segregation, CQRS. CQRS is a design pattern that separates read operations, queries, from write operations, commands. The main idea behind CQRS is to have different models for reading and writing data, which allows for more flexibility and scalability. Here's a detailed explanation. Commands represent actions that change the state of the application. Each command typically corresponds to a method that performs an operation, like creating a new user or updating a product. Queries represent actions that retrieve data without modifying the state of the application. Each query corresponds to a method that fetches data, like getting a list of users or retrieving order details. By separating these responsibilities, you can optimize read and write operations independently. For instance, you can use different databases or caching strategies for reads and writes. Mediator pattern. The mediator pattern is used to reduce direct dependencies between components, promoting loose coupling and single responsibility. In ASP NET Core, the mediator pattern is often implemented using the Mediatr library. The Mediatr library provides a simple mediator implementation that helps in handling commands and queries. Implementing CQRS and Mediatr in ASP NET Core. Let's implement a simple example of CQRS and the mediator pattern in an ASP NET Core application. We'll create a simple CRUD application for managing products. Step 1. Set up ASP NET Core project. Create a new ASP NET Core Web API project. .NET new Web API and CQRS_mediator_demo. cd CQRS_mediator_demo. Add the Mediatr and Mediatr extensions, Microsoft, dependency injection packages. .NET add package Mediatr. .NET add package Mediatr extensions, Microsoft, dependency injection. Step 2. Define the models. Create a product model. Public class product. Public int ID get, set. Public string name get, set. Public decimal price get, set. Step 3. Define the commands and queries. Create a folder named features and inside it, create folders for products, commands, and queries. Commands. Create a command to create a new product. Public class create product command, iRequest int. Public string name get, set. Public decimal price get, set. Create a handler for the command. Public class create product command handler, iRequest handler, create product command, int. Private read-only application DB context_context. Public create product command handler, application DB context. _context equals context. Public async task, int, handle, create product command request, cancellation token. Var product equals new product. Name equals request, name. Price equals request price. All. _context, products, add product. Await _context, save changes async, cancellation token. Return product, ID. Queries. Create a query to get a product by ID. Public class get product by ID query, iRequest product. Public int ID get, set. Create a handler for the query. Public class get product by ID query handler, iRequest handler, get product by ID query, product. Private read-only application DB context underscore context. Public get product by ID query handler, application DB context context. Underscore context equals context. Public async task, product, handle, get product by ID query request, cancellation token, cancellation token. Return await underscore context, products.find async, request.id. Step 4. Configure the DB context. Create a data folder and add an application DB context class. Public class application DB context, DB context. Public application DB context, DB context options, application DB context, options, base, options. Public DB set, product, products get, set. Step 5. Configure dependency injection. In startup.cs or program.cs, depending on your .NET version, register the necessary services. Public void configure services, iService collection services. Services.addDB context, application DB context, options equals. Options.use in memory database, in memory DB. Services.addMediatr, type off, startup. Services.addControllers. Step 6. Create the API endpoints. In the controllers folder, create a products controller. API controller. Route. API/controller. Public class products controller. Controller base. Private read-only iMediator underscore mediator. Public products controller, iMediator mediator. Underscore mediator equals mediator. HTTP post. Public async task, iAction result, create product command. var product ID equals await underscore mediator, send, command. Return OK, product ID. HTTP get, ID. Public async task, iAction result, get product by ID, in ID. var product equals await underscore mediator, send, new get product by ID query, ID equals ID. If product equals null. Return not found. Return OK, product. Complete example. Now you have a basic implementation of CQRS and the Mediatr pattern in an ASP NET Core application. You can run the application and use tools like Postman or curl to test the endpoints. To create a product, post/API/products. Content type, application/JSON. Name, sample product. Price, $10.99. To get a product by ID, get/API/product/1. This setup allows you to easily add more commands and queries as your application grows, maintaining a clean separation of concerns and leveraging the benefits of CQRS and the Mediatr pattern.